Thank you very much for the attention and the possibility to present my project. I'm actually a physicist at the Faculty of Nuclear Sciences and Physical Engineering, and also part-time at the Wigner Research Institute in Hungary. And I find it really an interesting perspective to work together with other universities all over Europe. And in general, I would like to see that quantum technologies has more presence all over in education and in general in the minds of people. So what I propose to do is to modernize an actually long-running lecture on quantum computing and quantum information. And the reason why it is necessary to modernize this teaching is because we used to be teaching this in a very old-fashioned way, which was the perception was that quantum computing is something which is very theoretical. It has all kinds of counterintuitive, weird effects that no one understands, even the physicists have no idea. But anyway, if anyone wants to do this, it should be a physicist, and it's for nobody else. And actually, this has already changed, and this is changing a lot these days. And what we know is that quantum technologies have a revolutionary potential. We're possibly living now through the second quantum revolution at this particular time. And there are already existing tools to use quantum computers, which give you a hands-on experience, and you can actually develop an intuition. It is really changing in the way that how we think of quantum computing. And I believe that basics of quantum computing should be open for anyone who has an open mind towards computer science and any IT technologies in the future. So what is this new tool in teaching that could be used? So these are these quantum programming software development kits. There are multiple of them. I just mentioned 3, but there are more. And these things, more than just simulating quantum mechanics. Okay? These are really languages that are meant to be used to program a quantum computer. And quantum computers exist. Okay? They are small, but they exist. So you can actually go and use these languages and connect through the cloud and program a quantum computer. What you can use them for, that's another question, but that is really the main question here. Who will be the people who figure out what these quantum computers can be used for? And this interface these software development kits are written in Python, which means that it very naturally fits into using Jupyter notebooks. And this is a proven thing. So I mentioned before that maybe I forgot to mention in the hassle that I'm also active in a global community, which is called the Q World. And at Q World, we're already running public workshops for over a year. We also have had one in Prague, which was also very successful. So this is a proven approach to teach people how to use quantum computers. And this is exactly what I would like to do. I would like to take this example and this well-tested environment and fit it to university education. And because of the nature it works, this is already beyond what is usually assumed as a usual classroom subject. Okay, and so the idea here is that by modernizing this subject, it will be more accessible to students, not only to physicists, but also to other, let's say, for example, quantum computer scientists. And this is already underway here, where I'm collaborating with Ivo Peter from the Faculty of Information Technology. And also, there's also an initiative within the Quantum Flagship. And I'm part of the coordinating team that is doing this pilot project on master programs. And I believe that these pan-European things can also extend it to not only to the large scale, but it can also be applied within a smaller community, which is the EuroTeQ. So with this, I thank you for your attention.